box. So kindly wait for a few minutes before we actually begin the session. Okay, so, all right. So hope all of you can hear my audio clearly, and if you are able to see the slides, kindly give a thumbs up. If both audio and the slides are perfect, please give a thumbs up in the chat box. Yes, hi Adityan, hi David, hi PL. Kindly wait for another 2-3 minutes before we actually begin. Yes, hi Srikar, thank you for your thumbs up. So others also, if you can hear the audio properly, kindly give a thumbs up. Okay, PL says it is clear. Thank you, PL. Yes, thank you, David. Yeah, hi, Pujit. I think I'm seeing Pujit for the first time in the chat box. All right. Hi, Adityan. I think Adityan submitted around 2 assignments for project 1. I had seen a couple of students who have submitted the assignment twice. Yes. Hi Bindu. Hi Kavya. So by the way, if you are facing any issue with the video, like blurred video, kindly go to the YouTube settings and just change the quality from 144 to 1080 or something that is larger according to your internet connection. Okay. Hi Shreyas. Kindly wait for another 1 or 2 minutes. Hi Sanjeevi. Hi Rosie. Oh, sorry. Hi Hansini. Yes. Now I'll remember your name. Hi Sanjeevi. I don't know whether that's the correct way. Hi Tejesh. Good evening. Hi Surya. Yeah. Yeah, today is the last class of this part 1, or if you want to call it season 1. So season 1 Vedic mathematics, the last class is today. Season 2 will be starting from next month onwards. Yes. Yes. Hi Ritvik. All right. Okay. So I have closed the project number 2, and I didn't see any more submissions. So what I'll do is I'll discuss the project in today's class. Okay. Okay, right. Yes. Hi Prashant. Hi Surendra. Hi Hanumatu. Good to see you here. Hanumatu has been very active on the chat, I guess. Hi Charan. So I don't know most of your actual names, but I'm just reading your names from the chat box. Yes, PL, the name is Satvik. Good. Oh, okay. So two students are attending there, PL. So Satvik and Rutvik. Okay, good. Yeah, good evening, Charan. So I think we are ready to get started. So if you want to just get started, give me a thumbs up in the chat box so that we can officially start the class. All right. So Adityan says yes. So let's continue from where we left yesterday. So this is the set of 9 sessions that we had. This is kind of the syllabus. So we started with the introduction and we learned about the 10-point circle. We learned how to do mental addition. After that, we went on to learn how to do completion. So that's the first important sutra, by completion and non-completion. An extension of that is the connecting of dots by addition and subtraction. So we had introduced to word problems and we had reviewed addition and subtraction methods. In week 2, we did some creative mathematics. We especially studied about doubling and halving operations. And then we learned about extending the multiplication table. So remember how we did multiplication by 5, 50, 25, etc. Then again in class, in week 2, we learned about finger mathematics. Anybody remembers finger mathematics now? Right? No response in the chat box. Okay, so finger mathematics is an easy way to use to do mathematics without a calculator. So we learned especially how to do multiplication table of 9 using finger mathematics. Okay, so Hanumatu says, yeah, he doesn't remember. Yes, finger mathematics I will be reviewing again in the part 2 of this course. So don't worry, Hanumatu, we will be repeating that. Okay, so in the third week, we did on Monday, we studied about the magic number of 9, what are its properties. And then in the last class, we started doing subtraction. That's yesterday's class. Now this class is also, we'll be doing a little bit more of subtraction and we will learn some word problems. Okay, so this lecture is titled The Power of Negative Thinking. So at home, most of your parents would say that always think positive, right? But when you come to mathematics class, some negative thinking is also good. We'll see how it is good. Okay. So for especially when you are doing subtraction, some kind of negative algebra is good to learn. All right. So let's start with the first sutra that we have learned for subtraction. What is it called? All from 9s and last from 10. So you need not learn about the Sanskrit name. Sometimes it is shortened and called as Nikhilam. This sutra is sometimes called as Nikhilam. It just means all from 9s and last from 10. So let's see what does this sutra say. So take a number like 876. How many places are there? There is a units place. There is a tens place. There is a hundredth place. I don't know if it's visible what I have written. So what I will do is I'll just use one letter each for each of the units and I'll use a different ink so that it is perfectly visible to all of you. Let me just try this. So 6 is in the units place. I'll write U for that. 7 is in the tenths place. So I'll write T. 8 is in the hundredths place. So H. Okay. Now, what does the sutra say is that suppose somebody went to the shop and purchased some item for 876 rupees and he gave 1,000 rupees as the amount to the cashier. Now, how much the cashier should return? This can be easily calculated from this sutra. How do we do that? All from 9s and last from 10. So what you should do is you consider all the places except the units place and you find the difference of those digits from 9. So what is 9 minus 8? It is 1. 9 minus 7? It is 2. And for the units place, you should subtract it from 10. So 10 minus 6, that is 4. So if you purchase something for 876 and you give 1,000 rupees to the cashier, you should get a balance of 124. Is that fine? Okay, if that is fine, let's go for the second one. You purchase something for 54 rupees. Maybe what do you get for 54 rupees? Maybe a notebook or a slightly costlier pen is 54 rupees. You have only 100 rupees with you. So how much change you should collect from the cashier? Again, you can apply all from 9s and last from 10. Here the units place is 4 and the tens place is 5. So you just take the places that are not in the units and you subtract that from 9. So 9 minus 5 is 4. Units place, remember, you should always subtract from 10. So 10 minus 4 is 6. So 46 is the answer. So I hope everyone gets it, because I can see most of you have written the answers in the chat box. Now here we have a single digit number. So what does this sutra say? Suppose you went to the shop and you bought 3 pencils. Each of these pencils were 3 rupees. So the total amount came to be 9. You had only 10 rupees, you gave it back 10. How much should you collect back? Everybody knows the answer, it's 1. Now if you were looking at the sutra, you will see that there is only a single units place. If there is only a single units place, you should do last from 10, because all from 9s is not required, because only you have units place. Now let's look at some additional problems. Okay, we have already done a similar problem. So now I'll just give you maybe 10 seconds to calculate what is 1000 minus 864. Your time starts now. Kindly put your answers down in the chat box. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, let me just see the chat box. As I can see, the first answer coming from Adityan. Hanumatu gives a different answer. I forgot the name of Rosie. What was your name? I forgot. At least in this, it is Rosie. I forgot what you had written in the chat box. Okay, so most of you give the same answer towards the end. Okay, let's check whether the answer is correct. So we just have to apply all from 9s and last from 10. So 9 minus 8 is 1, 9 minus 6 is 3, 10 minus 4 is 6. So the answer should be 136. So how many of you have done using this method? All right. Now we are going to check one thing. Yesterday, what did we learn? We learned about Navashesh. Everybody remembers what is Navashesh? Navashesh meaning digit sum. So now find the digit sum of 1000. Digit sum of 1000 is easy. It is equal to 1. Why? Because there is only a one non-zero digit. Digit sum here. How do you calculate? 8 plus 6 is 14. 14 plus 4. 14 plus 4 is 18. Is that right? 14 plus 4 is 18. So 18 has a digit sum of 9. So what you should do is 1 minus 9. 1 minus 9 is nothing but minus 8. Minus 8. So minus 8 should have a digit sum of 1. I'll tell you why. So for the time being, you believe that minus 8 has a digit sum of 1. I'll explain to you shortly how the digit sum of minus 8 is 1. Now calculate the digit sum of 136. 1 plus 3 is 4. 4 plus 6 is 10. 10 has a digit sum of 1. So you get 1 as the digit sum here, 1 as the digit sum here. So your answer is correct. So this is how you verify. All right. Are you comfortable with the Navashesh idea now? All right. Now I am going to tell you how the digit sum of -8 is going to be 1. So you look at this circle. I'm not sure whether you can see it or not. Yes, I think it is visible. So the 9-point circle is something like this. 9, 1, 2. Oh, I should draw a bigger circle. Let me use eraser. Okay, let's draw here. Okay, I'll draw it big this time. So we have a 9-point circle. 9 is here, 1 is here, 2 is here, 3, 4, 5, 6, 7, and 8. All right. So what number comes above 1? It is the number 10, because 10 has a digit sum of 1. Now find what is the difference between 10 and 1. 10 and 1, the difference is 9. So the next number that comes here is 11. What is the difference of 11 and 2? It is 9 again. What is the difference between 12 and 3? It is 9. So any number which has a difference of 9 will have the digit sum as the same. So what I mean is that the next number here is 19, the next number here is 20, the next one here is 21. So what is the difference between 19 and 10? The difference is 9 again. What is the difference between 20 and 11? The answer is 9. So whenever two numbers have the difference as 9, they both will have the digit sum the same. So in this case, -8 plus 9 is 1. So the digit sum of -8 should be exactly 1. So if you have understood, you can wave your hands in the chat box. Kindly wave your hands if you have understood this idea, so that we can proceed to the next problem. All right, David waves the hand. Okay, so Manvita asks, what does 46 represent in 54? Okay, so I think some of the students might get confused by that. So let me just explain that. I'll just erase this 9-point circle that I had given here. And let me go to 54. Good that Manvita has looked into this. So let me just erase these parts so that I can explain. So imagine that you went to a shop, you bought something for 54 rupees, maybe a costly notebook, a 200-page notebook. It is 54 rupees. You had only 100 rupees with you and you gave that to the cashier. Now, how much should the cashier return? That's a question. All right. So how do you calculate that? For calculating that, you have got a sutra, and that sutra is called as all from 9s and last from 10. So first of all, what you should do is identify the units and tens place. Here 4 is in the units place, tens place is 5. So for doing 100 minus 54, what you do is you identify all the numbers except the units place and you subtract the digits from 9. So here the digit is 5. So you should do 9 minus 5. 9 minus 5 is 4. In the units place, you should do 10 minus that units place digit. Here it's 4. So 10 minus 4 is 6. So that's why the answer is 46. So hope it was clear, Manvita. Alright, so let's go for one more practice problem. You should now try to do what is 1000 minus 307. This time I'll give you exactly 5 seconds. I'm going to reduce the time. So 5, 4, 3, 2, and 1. Okay. So I can see the answer from Sirisha first, Saumya, All of you give different answers. VSS. All right. These are the first few answers that came in. Let's do this. Again, we can apply the same sutra. All from 9s, last from 10. So 9 minus 3 is 6. 9 minus 0 is 9. 10 minus 7. 10 minus 7 is how much? 3. So the answer should be 693. Now, whenever you go to shop, whenever you are paying something like 100 rupees or 1000 rupees or 2000 rupees, you can apply this sutra very easily, and you can get back home quickly. All right. Yeah, I think some of you give a different answer, 703. Some of you are writing that in the chat box. Some of you have given the answer as 793, which is not right. The answer should be 693. Okay. Let's do this one. This time it is a larger number. 10,000 minus 6,523. Now I'll give you 5 seconds. 5, 4, 3, 2, and 1. Okay, Sirisha has the fastest finger, it seems. Okay, Rosie is asking what about the project. Yes, I'm going to discuss the project after I discuss some of the initial slides. All right. So Sirisha gives answer. I think most of you are giving the same answer. Right. So all from 9s, last from 10th. 9 minus 6 is 3. 9 minus 5 is 4. 9 minus 2 is 7. 10 minus 3. The last digit should be subtracted from 10. So 10 minus 3 is 7. So the answer is 3477. Good. Now here is the last one. I'll give you only 2 seconds this time. Shall I start? 2 and 1. Oh, nobody gives the answer in 2 seconds. I thought it was easy. Okay, this time I can see new entrants. Sirisha gives, VSS gives, Ritu gives, Hanumatu. I think Hanumatu had given a different answer. The answer is 37. It's quite direct. 9 minus 6 is 3. 10 minus 3 is 7. Now, we are ready to go to the next part now. After that, after solving these word problems, I'll discuss the homework problem. Okay, not the homework problem, the project problem. So this was a problem that was given as homework yesterday. I don't know if you have done this. So I'll read the question. The question reads, a garment factory had manufactured, how many zeros are there? 5 zeros. So this is around 1 lakh or 100,000 trousers, out of which 34,925 were exported. So how many trousers remained in the factory? Yeah, so when you say about trousers, it just means this item over here. It's not important as far as the question is concerned. You just want to find what is the difference of this 1 lakh and 34,925. So if you were just learning this in school, what you will do is you will write this 1 lakh like this. You will write 34,925 like this, and you will subtract. How will you subtract? Yes, 5. You will start from the right, no? When you do it in school, you generally start from the right. So 0 minus 5 you cannot do, so you should borrow. So I cannot borrow from here because it's 0, here 0, here 0, here 0. So finally I should borrow from here. So if I borrow from here, this will become 0, this will become 10. But then 10 I have to give a carry to the next place. So this place will become 9, this place is 9, this place is 9, this place is 9, this place is 10. So this is exactly what we learned in the previous sutra. What did we learn? All from 9 and last from 10. So if you just remember this, you need not write these subtraction like this in your notebook or the answer paper. So how do you do this? You just do 9 minus 3. What is 9 minus 3? It is 6. 9 minus 4 is 5. 9 minus 9 is 0. 9 minus 2 is 7. 10 minus 5 is 5. So after exporting, then the number of garments or number of trousers that remain in the factory is 65,075. So I can see most of you have got the answer. Hope you have applied all from 9s and last from 10. All right, here is a second problem for you. This will be a slightly difficult problem I'm going to give you. So this is a supermarket problem. So Susan went to the supermarket with her mother and purchased the following. So they purchased a toothpaste which is worth 144.5 rupees, a rice which is amounting to 183.25, noodles for 56.15, and some cupcakes for 120.05. All right. So Susan went to the cash counter and paid rupees 500. Now you should calculate what is the difference amount she should receive as balance. Yeah. So I can see some of you are writing the toothpaste is quite costly. Yes, this is a very costly supreme quality toothpaste, you can imagine. Yes. Hi Pavan, I remember you. Yes, so I'm just looking into the chat box. I'll wait for the first answer to come, then I'll start solving. Yes, hi Lakshmi. Yeah, kindly solve the problem. Yes, Pavan is asking, kindly explain the problem once again. All right. The problem is quite direct. Imagine that you went to the supermarket with your mother and you purchased these 4 items. And your mother paid 500 rupees. Now you had to calculate what is the balance that you should get. Yes, I can see many different answers coming in. Let's see what is the correct answer. Okay, so I can see answers coming in. So let me start solving. So how do we start solving? I'll start with the decimal part. So we have decimal part in each of this. So 50 plus 25 is 75, 75 plus 15 is 90, 90 plus 0.05 is 95. So the decimal part alone is 0.95. Now you can add the remaining. So 6 plus 4 is 10. So this will become 150, 150 plus 50, 200, 200 plus 180, 380, 380 plus 120 is 500. So this should be 503. So 503.95. Is that right? I think yes. Yes, Adityan says 503.95 is greater than 500, which is a good observation. It's correct. So actually, Susan should hand over 3 rupees and 95 paise back to the cashier because you have only given an amount which is less. So this is what is called as, so if I subtract 500 minus 503.95, this subtraction is not possible because it is less than 0. It is a negative number. So this is what you call it as a negative number. Okay. So whenever you get the balance to be a negative number, what you should do? You should give the remaining amount. The remaining amount here is 3 rupees and 95 paise. That you should give back to the cashier. Now, what is today's lecture's name? The power of negative thinking, right? So let's see how we can use these negative numbers to do subtraction more easily. In the next part, I'm going to explain that. So this topic is called as bar numbers. It's also sometimes called as vinculum. This is an English term. I'll just explain what a vinculum is. So we'll begin as usual with a story. All right. So there is this two people who are there. Their name is called Pi. This is called as Jumbo Pi. So Jumbo Pi. And this is called as the Little Pi. Okay, everybody knows the number pi, right? Maybe when you draw the circle, somebody asks you what is the circumference of the circle, you write it as 2 pi r, or maybe the area is pi r squared. So the same pi is there. One is a jumbo pi and the other is a little pi. Now the little pi always likes to sit on jumbo pi. Okay. So whenever little pi sits over jumbo pi, any problem can be easily solved. So once the two pies, jumbo pi and little pi, were going and they found a small door, but the jumbo pi's height was too high and he could not cross it alone. So what happened? So little pi came to help and he sat over jumbo pi and they could easily go inside. Okay, so that is the story. Now let's see what is the mathematics behind this story. So what we are going to learn here is what is called as bar numbers. So here you can see a little pi that is sitting over 2. So little pi is sitting over the second number, which is 2. Everybody can see a small line over the number 2. Okay, so in the chat box I can see many of you are discussing about the value of pi. That value of pi is not very important in what we are learning right now. So kindly focus on what is being discussed. So I just took pi because it is a very well-known number. You can come back to the number here, 72 bar, 72 bar. Okay, so this is what is called as a bar number, and you can see a little pi which is sitting on top of 2. Yes, some of you are writing in the chat box it is 7.2222 etc. No, so this is different from that notation. So many of you are just talking about 7.2 bar. So this is what is 7.22222 etc. But this is 72 bar. There is no decimal point in between. Now the value of 72 bar can be written as 70. Whenever a bar comes, you should put a subtraction sign and then you should write that particular number. So here the bar is over the units place, so this is 70 minus 2, which is equal to 68. All of you got what is this? Okay, I think some separate discussion is going on in the chat box regarding the value of pi. So kindly come back to the class and tell me what is 72 bar. All right, so I'll give you another example. You have to type in the chat box what is 861 bar. There is only bar over 1. Okay, so Himanshi is asking, in fraction the line which divides the numerator and denominator is known as vinculum. Yes, that is also correct. Yes, Himanshi has got a very nice observation. So any line which is written in a fraction, that is also called as vinculum. So here the vinculum is representing a bar number. Okay, so I guess somebody gives the correct answer. PL, yes, PL gives the answer as 859, which I think is correct. Why is 859 correct? Because 861 bar is same as 860. This is the units place. So 860 minus 1, 860 minus 1 is 859. All right, so I can see many of you have given the correct answer. Yes, Pavan, I have seen your answer also. Adityan, you have written as 85. It is not 85 because it's a 3-digit number. So it should be, the answer also should be a 3-digit number. Okay. Okay, so Sirisha asks why it is not 861 minus 1. Yes, I told you earlier, you should write the numbers from left to right and whenever the number is there with the bar, there you should put a 0. There you should put a 0 and then write minus that number. So that is the rule. Yes. So the answer to this third question is 127. The last digit is having that bar, so you put a 0 and you subtract 2. So the answer should be 1268. Yes. Pavan, Charan, PL, Rosie, Ritu, you are all right. Okay. Now here is an exercise. You should read it carefully. There are 2 problems that are going to appear and you will get around 1 minute. Okay, this is the problem. Express the number 117 as a bar number. So you should express the number 117 with a bar. Your time starts now. Okay, there is no single answer for this. There can be many answers. There is no single answer. Yes, Deepika gives one answer. PL gives another answer. All right, there is some other answer coming from Ritu, Adityan, Pavan. Yes, your times ends there. Okay, so one possible answer is, of course, you can write 117 as equal to 120 minus 3. So this is equivalent to writing 1 2 3 bar. Got it? Now somebody may give a different answer. What is a different answer? You can write 117 also as 130 minus 13. So this is also correct answer, but now you have to be a little bit careful. Okay, so here when you write the bar number, you should do a similar thing. You can do 1 because there is no hundreds place here, so you can write 1 minus 0 is 1, 3 minus 1, 3 minus 1 is 2, 0 minus 3, 0 minus 3 is a negative number, so you can write it as 3 bar. Yes, Sirisha, you are right. It is 1 2 3 bar. Now let's go for the second problem. Get ready with your pen and paper. You will be given exactly 1 minute. Okay, so express 570 as a bar number. Your time starts now. Express the number 570 as a bar number. Yes. Yes, Surya, I will explain this once again. Don't worry. So your time is going to end about 15 seconds more. Yes. And your time stops there. Yes, Adityan just gives the answer as 570, which is fine. I think some of you were not able to apply this. So PL says it is 582. 2 is bar 0. 582. I don't think that is the correct answer. Let me just give you an example. So 570 can be written as 600 minus 30. Everyone agrees? 570 can be written as 600 minus 30. So 6 can be written. 0 minus 3 is a negative number. You can write 3 bar and the last number is 0. So this bar can come in the middle number also. It can come at any place. Yes. So Deepika gives the correct answer 6 3 bar 0. Now are there any other methods to write this? The answer is yes. You can write it in many ways. You can write as somebody has put it 572, but you have to be careful. Let me tell why 572 is not correct. So 572 bar, if you write, this is equivalent to 570 minus 2 and the answer is 568 and it's not equal to 570. So 572 is not the right answer. Only possibility I think is writing it as 6 3 bar 0. All right, so I can see somebody is wanting to explain this once again. So let me just go back and let me just explain from this simple examples. So everybody understood the story of pi. So whenever there is this little pi over the jumbo pi, problems get solved. So that is the same idea that we are using bar numbers. When we do subtraction using bar numbers, the problem becomes so easy and it can be quickly solved. That is the idea of learning bar numbers. Now look at the number 7 2 bar. There is a little pi which is sitting over 2. So whenever a little pi is sitting over a number, you should write it as minus. So this should be minus 2. So 2 is in which place? Units place. Now what is there in the tens place? It is 7. So tens place, the value is 10. So you should write it as 70. So the answer is 70 minus 2 or 68. The same number 7 2 bar is representing the actual number 68. Okay, Shreyas says I'm not looking at his answer. Yeah, sorry Shreyas, I'll just look into the chat box when you're typing. Okay, next time I'll just look your answer once again. Okay, so let's go back to this second example, 861. So what is 861? In this, the units place is 1. So you can write this as 860 minus 1 because the bar is placed over 1. So the answer is 859. What is 1272? It is 1270 minus 2, which is 1268. Now here I am going to give you another additional practice problem for you. Let me use a different ink here. Let me use a green color here. So all of you should write in your chat box, what does the number 1 2 bar 7 2 represent? What is this without using bar? So the little pi is sitting over 2 here. So I'll give you exactly 10 seconds this time. Your counter starts now. 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. Okay, so I can see some of the answers have come. Surya has given the answer. I think Pavan has erased the answer, is it? Yes, Charan gives a different answer. Charan, you are close, but that is not the correct answer. I think Surya's answer 872 is correct. Why is it correct? You write the first number. This is in the thousands place. This is units, tens, hundreds, thousands. So 1000. The next number is a minus number, negative. So this comes in the hundreds place. So you should write it as minus 200 because this is in the hundredth place. Next number, there is no bar on top. So this is 70 plus 2. Now you can do usual addition. 1000 minus 200, that is 800. 800 plus 70 is 870. 870 plus 2 is going to be 872. So the answer is going to be 872. All of you understood till this much? If you have not understood this completely also, don't worry so much because we are going to do practice problems in the next slide. So don't worry so much. Only thing that you have to remember is whenever any number, any digit has a bar on top of it, you should do subtraction. All right. So let us learn how to do subtraction using bar numbers. I will do an example. After that, we can try. So Manvida, kindly wait till we complete this. After that, I'll explain to you your doubt. So this problem, you have to do subtraction of 7,312 and 3,765. So first of all, you take the last digit. So this is from left to right. 7 minus 3 is what? 7 minus 3, we know it's 4. 3 minus 7. Yesterday we said that in the cricket match, the second batsman, if he has scored less runs, he has to borrow from the next person. But now, since we have learned bar numbers, what will we do is that we will do the subtraction like this. So 3 minus 7 is not possible, but we can do 7 minus 3. What is 7 minus 3? 7 minus 3 is 4, and on top of 4 we will put that bar number. Next place you look, it is 1 minus 6, which we cannot do, so you do 6 minus 1, which is 5. 5 you write and put a bar on top of that. And the last number is 2 minus 5, again you cannot do that, so what you have to do, 5 minus 2 and put 3 and a bar on top of it. Now how do we calculate this number? We know how to convert a bar number to a usual number. How do we do that? 4,000, because this is in the thousands place, fourth digit is thousands place, minus 400 minus 50 minus 3. So 4,000 minus 400 is what? 3,600. 3,600 minus 50 is how much? 3,550. 3,550 minus 3 is how much? 3,547. So this is the correct answer. All right. So I can see most of you have written the answer. So hope you have understood it. Now I'm going to give you two practice problems and you're going to solve it on your notebook, and after that we will revise once again. So your first practice problem is 905 minus 447. Now the timer starts running now. So use the idea of bar numbers. Yes, Jagruti says okay, Jagruti is writing something in the chat box. Okay, I think some discussion, internal discussion is happening in the chat box. Yes, I can see answers coming from Saumya, Lakshmi and Adityan. We don't know, we cannot decide which is the correct answer because the time has not ended. Let me just wait till the timer has gone to 0. So again, maybe you will have 10 more seconds. Speed up. Yes, Shreyas, I can see your answer. Yes, Lakshmi is asking, can you explain it again? Yes, I will explain this. Just listen to the practice problems, how I am going to discuss. By that, you will become clear. Okay, so the timer has ended. So let me solve this. You will start from left to right because that is the easiest method. 9 minus 4, everybody knows it is 5. 0 minus 4, you cannot do. So what you will do is 4 minus 0. You will write the answer as 4 and put a bar on top of that. 5 minus 7 you cannot do, but you can do 7 minus 5. 7 minus 5 is 2 with a bar on top. How many of you understood till this point how to write this subtraction in the form of a bar number? Yes. So Lakshmi is requesting for explaining this again. Have you understood how to write the number 5, 4 bar, 2 bar? Yes, Lakshmi says the answer is 468. We will come to the answer, but I want those who have understood how we got 5, 4 bar, 2 bar. Can you give a thumbs up in the chat box? No? Yes? Don't care? I don't see any response in the chat box. Yes, I can see Pavan is writing, I guess. Aditya gives yes. What about others? So Lakshmi, you said you wanted to explain that again. So let me just go over this slowly. So I'm going to take the last digit over here. It is 9 and 4. The difference is 5. That's why I write 5. In the second position, the digits are 0 and 4. Which is greater? 4 or 0? 4, right? 0 is less than 4. 4 is a greater number. So you cannot subtract 0 and 4. So what do? You subtract 4 minus 0, the opposite way. Since you have subtracted it as an opposite number, you have to put a small bar or line on top of that number. Understood? Likansha, have you understood that? So Likansha has been giving a thumbs down because I think she has not understood it well. So let me just explain that. The tens place here, the digits are 0 and 4. So I cannot do 0 minus 4. Why? Because 0 is a smaller number than 4. So what you should do is 4 minus 0. 4 minus 0 is 4. But you should put a bar on top of that or a line on top of that. Now coming to the last place, what I have to do is 5 minus 7. 5 is a smaller number. So you should do only 7 minus 5. The answer is 2. And you should put a bar or a line on top of that. So what will be the answer now? This is same as 500 minus 40 minus 2. 500 minus 40 is what? 560. Sorry, 460. 460 minus 2. 460 minus 2 is 458. So this is the correct answer. Somebody has given the answer as 468. Very few people have written 458. I think Rosie Reddy, Adityan, and some new name I have seen. Prashant has given the correct answer, 458. Most of you had written as 468. So it is 458. Shreyas has given the correct answer. Good. Alright, Shreyas is requesting, can we do the class up to 7 p.m.? I don't know. Many students may want to leave the class early. Let us see if there are more requests, then we can stay. Now I'll give you one more practice problem, and this is a very large number. So I'll give you again some time. Your time starts now. Start solving on your notebook. All right. So you should solve it fast because it's a 5-digit subtraction. Yes, Lakshmi says it is 458. Yes, 458 was the answer for the previous question. So you have almost only 20 seconds. So speed up. I don't see any answers coming in the chat box. Is it very difficult to do this one? Okay, first answer comes from Adityan. David, VSS, Surya. Yes, I can see your answers. The time has ended, so I'll just solve it. So let me just change the ink. I think the green color is not very pleasing. So let me just use this. So this time I'll just draw the box so that you can get it clearly. So 5 minus 1 is 4. Now 1 minus 8 I cannot do, so I'll do 8 minus 1, which is 7, and I'll put a bar number on top of that. 3 minus 7 I cannot do, so I'll do 7 minus 3, which is 4, and put a bar on top of that. 2 minus 4 I cannot do, so I'll do 4 minus 2, 2, and I'll write a bar on top of that. And the last number is 4 minus 5, which is also not possible to do, so I'll do 5 minus 4, which is 1, and write a bar on top of that. Alright, now I'm going to give you a very easy method to write what is the normal number corresponding to this number. So the number is 4, 7 bar, 4 bar, 2 bar, 1 bar. So before I do that, Lakshmi and Likansha, have you understood how we got this number? 4, 7 bar, 4 bar, 2 bar, 1 bar. If you have understood, kindly wave your hands in the chat box. I'll just give you 10 seconds. Likansha and Lakshmi, have you understood it? So Likansha says yes, she has understood that. Oh, Lakshmi says it's no. Okay, so let me go back to the problem. All right. So, which is the leftmost number here? This is the left side, this is the right side, right? So we are going from left to right. So left to right subtraction. So you consider only one digit at a time. So first digit is 5 and 1. 5 is larger. The upper number is larger. So you can do subtraction. So what is subtraction of 5 and 1? It is 4. What is the second place? So you are in this place now. You should do 1 minus 8. So 1 minus 8 is nothing but, you're gonna do that. So you have to do 8 minus 1, 7. But since you have done the opposite way, you have to put a bar on top. So hope you have understood that. Is it clear the second number? Lakshmi, have you understood the second number? Why we wrote 7 and bar on top? Yes. So Lakshmi says yes. So I think the remaining also you can solve. Next number is 3 and 7. So you should do 3 minus 7, which is not possible. So do the other way, 7 minus 3, which is 4. Put a bar number on top. So finally, when you do for each and every digit, you get the final answer as 4, 7, 7 bar, 4 bar, 2 bar, 1 bar. Now to solve this, what you can do is, whenever a number is followed by all other digits having a bar on top, what you can do is, you cut this number, the first number, and subtract 1. Write 3 there. So 4 minus 1 is 3. The remaining you can do all from 9s and last from 10s. So what is 9 minus 7? It is 2. What is 9 minus 4? It is 5. What is 9 minus 2? It is 7. What is the last number? It should be 10, because all from 9s and last from 10. 10 minus 1 is 9. So the correct answer is 32,579. Let me just check who all have got the answer. So Surya has got the answer. Adityan has got the answer. Rosie has made a small mistake. Pavan has got the answer. Shreyas, you had given, okay, yes, your answer is correct. Rosie has corrected the answer. No, the second answer that you provided is also slightly an error. All right. So I think we have to end the discussion now, and I'll just discuss briefly the project. Okay. Right. So Tejesh is reminding me about the project. So we had 2 questions in project 2. These are fairly direct questions. So we'll discuss it here. Right. Again, we have around 5 minutes. Maybe I'll just take. So let's start with the project. If you want to start with the project, just give a thumbs up in the chat box. Okay, Pavan says, can you request for Zoom in the next class? Okay. So let's see whether it's possible in Zoom. I don't know. I think mostly we will do only through YouTube. Let's check. Okay, Adityan gives the thumbs up. Somebody else is also giving thumbs up. Okay, Charan. So these are very straightforward questions. So I'll just take 2 minutes to explain that. So question 1 reads the following. The size of an atom is 1.2 into 10 raised to minus 10. So don't worry when you're reading this number. Even if you have not understood what it means, you can solve it. Now the size of one atom, an atom meaning one atom is this much. Then what is the size of two atoms? It's direct, right? You just have to multiply by 2. So this is doubling. So you just have to double this number, 1.2 into 10 power minus 10. So what is double? Double of 1.2, double of 12 is what? 24. So 1.2 is just 12 by 10. So you just have to do 24 by 10. So the answer is 2.4 into 10 power minus 10. Okay. So I don't know, somebody Stagesh writes it's 10 power 10 power 10 power minus 4. Okay, so this is what is called as an exponent. It is meaning that this atom size is very small, it is very microscopic. 10 power minus 10 meaning just it's very small. Okay, so hope you have understood that. Now we are going to the second part. So hope you are all hungry. So I have bought you pizzas. Okay. Now you have to divide the pizzas among yourself. So there are 5 students here and they wish to share this pizza, and the circumference of this pizza, it's a round pizza, the circumference, the length of this, whatever the outer, that is 12 centimeters. Now when you divide this 12 centimeters into 5, what is the arc length? So arc length meaning what is the length of this part that each person gets. Have you understood the problem? So 5 students wants to share this pizza, and the total circumference meaning you can call it as perimeter also. Perimeter or circumference, it is the length of the outer circle, that is 12 centimeters. Now you have to calculate what is the length of each piece. So the answer is so direct, it is 12 divided by 5. We learned how to do 12 divided by 5 in the last class. We will divide by 10 and multiply by 2, because 10 is 5 multiplied by 2. So what is this? 24 divided by 10, the answer is 2.4. So it's fairly direct. Have you understood? Yes. Okay. So I think we can end today's class, and I'll just wait for some time till I take some questions if you have any. If you feel like you have understood the lecture, you can take a leave and come back for season 2, which is going to start next month. Okay, so this will end the first season of Vedic mathematics. The next season is going to come in the next month. Okay, right. So I'll just wait for 2 or 3 minutes, maximum of 5 minutes, to take questions. Others who wish to leave the session can leave. Okay, so Manvida says, can you repeat 9-point circle? I didn't understand. So very good. So let me just explain that for Manvita. So 9-point circle meaning the following. You will just write, first of all you will draw a circle and you will indicate numbers from 1 to 9. So 9 is the number that is going to come on top, and you will have 1 here, you will have 2 here, you will have 3 here, 4 here, 5 here, 6, 7 and 8. Now why is this circle important? It is important because of the following. Because when you add opposite numbers 8 and 1, 7 and 2, 6 and 3, 5 and 4. All these numbers are going to add to 9. That is why this 9-point circle is important. And we also learned that we can calculate what is called as the digit sum. So, what is the next number after 9? It is 10. What is the sum of digits of 10? It is 1 plus 0, which is equal to 1. So, that can be found easily using the 9-point circle. I'll just write the second numbers here, which is 11, 12, 13, 14, 15, 16, 17, 18. So you look at the number 18. The sum of digit is 1 plus 8. 1 plus 8 is 9. Okay. So similarly, any number you can find the digit sum easily using the 9-point circle. So hope, Manvita, that answers your question. So many of you have left the meeting, I can see. So hope you enjoyed this first part of Vedic Max. So we'll meet again sometime next month. So till then, let's take a leave. Thank you and namaste. Okay, I can see some more chat coming in. So Hanumatu says, if you give 1,000 number, how can we solve? So you mean subtraction, 1,000 number. All right. So probably that is answered in the second part of Vedic Maths. So Hanumatu, you have to wait till the next part. Okay, come back for the next part. All right. So bye and namaste.